So this video is going to be about the oil pump and how the oil pump can impact your mileage. So what I have here is the original oil pump out of my 1974. And it is an oil pump that is used with dished cams, so it's fairly fat in this direction. So it doesn't work with aftermarket flat cams and the bolts and all that stuff that go around. They end up smacking back in here. And this doesn't fit down into the notch in the camshaft itself, which means your oil screw would stick out like that. It wouldn't fit down inside the pump. But they make plenty of aftermarket pumps that will work in a late model with the aftermarket camshafts. So let's take a look at some of that stuff. So the first thing you want to discuss is the sizes of oil pumps that you can get. And if you dig around here, I mean, there's a size for everything you want, and every single one of these pumps can be put into a late model dual relief case, and that includes the 21mm pumps that were designed for the single relief case. You can make them work. I haven't done it, but you could do it. And you know, if you want to save some power, why run a 26 if you can run a 21? Some people like to run the 30s. I used to think that I was running a 30, but I believe that I'm actually running a 26 in both of my cars. I'd have to go measure this stuff, but I think I'm running 26s. Anyway, there is, if I can get to it, of course I'm running Mofoco lifters. So this is Mofoco's Facebook page, and Mofoco has a whole bunch of motors that they have on display that they built. This happens to be, if I'm not mistaken, a 2276, so it's a good size motor. And you'll notice that he's got a filter right there. Let's take a closer look. He's got a filter pump, and he sells, if I can get it up here, this filter pump. So this thing is an MP9206, and I figured this thing had a pretty typical sized set of gears in it. It says it's a high capacity pump, provides added pressure, etc., etc. This is true, and of course it's hydraulic lifters, you might want a little pressure. But I didn't realize how big the gears were on this until I went and actually found somebody else who's posted it. So it's an MP9206, which is the flat cams. The 9207 are the dish cams, but they're both the same, but they have inside them 31.9 or about 32mm gears. Very big pump, so you can go all the way from 21 at the low end, 26, 30, and 32mm. Personally, I don't think I would do this, but yeah, apparently Mofoco sells a bunch of these things. This is the oil flow. So this, again, this is in the Samba, if you can see that right there. So we've got a Samba posting. Somebody's gone out and done a whole bunch of investigating. Apparently this was done back in, I think the guy said 1979. And they put together 100 motors. And this was for a project where they were potentially going to take air-cooled motors and pop them into inexpensive mini helicopters. So, interesting application. But they tested a whole bunch of motors for flow rates, which are listed right there, and pressures and pressures and pressures. They stuck pressure gauges all over the motor. So he's got a fairly decent amount of data here. The flows are right. Of course, you've got the pressure. Actually, this is the cooler bypass, and over here would be the pressure relief. So, dual relief case. You know, hopefully you're running the dual relief case. This is what I've got going on mine. And down here, the 26mm oil pumps. So the entire pile of stuff was done with 26mm oil pumps. But what he's got here from flow rates is anywhere from a low. Incidentally, this is all done at, I don't know if you can read that, 3,000 RPM. So this is pretty close to what we would consider to be a highway speed. So we've got a low of 3.17, an average of 3.31, and a high of 3.42. This is in gallons per minute, which is going to be important when we start doing the horsepower computation of the pumps. So that's 26mm to that, and the pressure ranges up here. This temperature, this particular system is a warmed up motor at 190 plus degrees. So this is a very warm motor, so the oil is flowing out to the cooler. And they're picking up at the pressure center oil pressures from 25 at the bottom end to a high of 48. If you go back to my motor and you look at some of my videos, I'm running, I believe, at about 55 psi at 3200, and I think the Hot VW guys with that CB motor, I think they say that they're running at about 45 psi. So in my computations, I'm going to use the 45 psi that they're running at, and 55 or 60 that I'm running at, just for some comparison purposes. But if you've ever wondered about the flow of the oil and how the pressures and stuff works, very good link over here on the Samba. All right, the next piece you have to look at is what is the actual horsepower requirement. And we've got somebody here who says, what do you believe the horsepower of the oil pump to be? Because this is an oil pump 26 or 30 millimeter gear discussion here. And this guy's saying, okay, I'm guessing that the horsepower is about 2 to 3 horsepower. If you read this, it's like, yeah, that seems to be the generally accepted wisdom, is that there's a rather large amount of horsepower being blown out. Alright, here's a good one. Okay, larger pumps require more horsepower. This is true. I believe it has been measured at a 10 horsepower increase. I believe that the author of this one right here has confused the oil pump horsepower with the fan horsepower, but that's okay. Says I've not measured it himself. It's true. I mean, it's hard to measure the oil pump by turning it on and off. You can't turn it on and off. You got to flow oil. You can pull the fan by just popping the belt, but you can't really turn off your oil pump. Okay, the trade-off is more power sucked off pushing a larger pump, which is not insignificant. Okay, again, this is generally accepted wisdom. Okay, we got a cool dude right here who's actually done some math. Very good. I've actually PM'd with this guy to verify that what I've come up with matches what he's come up with. Let's see, we've got a generally accepted bit of wisdom, 1 horsepower per gallon of oil at 100 psi. Nah, whatever, that's not how it works. There's a guy who's actually comparing the flow of oil to voltage through a system, which is an accurate comparison. Alright, we've got another guy here, very good, who has come up and decided to throw his 2 cents worth into the discussion of how much power the oil pump takes. And yes, he is correct. He's got his oil pump down and his air pump up, so that's good. It was an interesting read through here, and the general thought is that the oil pump takes a lot of horsepower. Let's actually see how much horsepower the pumps actually take. So here it is, the oil pump spreadsheet. But before we get into this thing of beauty right here, I want to tell you where some of the formulas came from. So let's take a look at that real fast. Okay, given that I don't actually have data for the pumps, I have data for a particular pump in a particular series of motors. You have to be able to compute the values for all the pumps. So this happens to be a website from a pump manufacturer. There they are right there. And they have conveniently given us a formula for gear pumps. So they've done some analysis that goes beyond simple mathematics. It uses this pump. This is a GIF, so it may jump on us. That goes to the other type of pump. But anyway, they've got the 2 pumps. We've got this particular formula. This formula is plugged into my spreadsheet. There's the bright pump. And ultimately, once we found the volume of the pump, you jump over to Wikipedia. From the volume, I can calculate the gallons per minute. I can get the oils, pounds per. This is happens to be pounds in cubic inches, and a constant, and that'll tell you what the power is. So if I've got a pump capacity, RPMs, flow rates, I can calculate the power. And this is in Wikipedia for the gear pump. So that's where my stuff comes from. When I come back over here to my spreadsheet, all right, I've got some numbers down here. These are like the mathematical representations, the pure math. If you go with the pure math on these things right here, you'll get these numbers, and you end up with like a volume of 4.63 gallons per minute at this particular rate. And utilizing the formula from the website, I'm coming up with a volume of, it should be for this one right here. Where is it? There it is. 4.99. think I've got my RPMs a little bit different here. But anyway, the numbers do correspond. This will be a high number. This is a good starting point for the gallons per minute. But let's take a look at what we've got right here. RPM 3200, that's about highway speed. The cam turns at half that, 1600. We're going to use the Hot VW's mileage rating, 29.9. The oil pressures that they got, for the most part, was about 45. I run at about 55, but I've got some different things in my motor that they don't have, so it makes sense that my pressure might be a little bit higher than theirs at the center. I've also got the 21 millimeter gear, the 26, the 30, and the 32. We've got some gear measurements. They are the same for every one of these things, with the exception of the length of the gear. This gives you a volume in cubic centimeters per revolution. That can be taken down to gallons per minute, so we've got a gallon per minute reading. We have an efficiency. I've got 80% in here. These pumps typically run at about 85% efficiency. But since our pressure sender is not actually at the exit of the pump, I'm going to penalize us an additional 5%. And ultimately you come down here and these are the horsepower readings you get. The smallest pump, the 21 millimeter at the lowest pressure, 0.13 horsepower. This is nowhere near as high as what the typical Samba guy would think that the horsepower rating is. And all the way up here at this monster pump, let's take a look, 0.27. So I've got a range. I can double my horsepower. So I went from a 21 to a 32, and I raised my pressure from 45 to 60. I've doubled my horsepower. Now I can do a mileage estimate. Now in order to do these mileage estimates through here, you have to have some kind of a starting horsepower estimate of what it takes to go down the road. I'm going to estimate that it takes about 25 horsepower to do 65 miles an hour. I think that's actually conservative. I think it actually takes a little bit more than that. The bigger the number, the smaller the difference the pump gear is going to make. But anyway, when you put it together, if I start with, let's say, the size 26, which is what they're using on the Hot VW's motor, the 29.9, of course we got a 1-to-1. If I were to take that and run my pressures, I would lose a little tiny bit. That's very, very little. If we drop to the smaller pump, which is what you might be tempted to do, I was able to get, what is that, 0.04 of a mile per gallon. That's about 1/10 of 1%. So that's not very much. All right, so if you put one of these monster pumps in here, the monster pump is going to take a little bit more energy away from you. So let's go to the big pump with the biggest pressure. And we've dropped less than 0.5%, which equates to about 1.2 miles, 0.12 miles per gallon. Sorry, so that's not very much change. Which means, once again, we have a component that, try as we might to try and drop the power and get us a little bit more mileage, it doesn't really make all that much difference. So for me, running hydraulic lifters, I think I'm running a 26. I got to go do some measuring. I'll figure it out. I'm not gonna bother with this video, but I think I'm running a 26. I used to think I was doing 30. I think I got 26. I think you could run a 30 without a problem. And apparently Mofoco, he's up there running this guy right here, and he's doing just fine with it as well. So there you go. There's your horsepower difference. Not very much. Not very much. You neither drop nor gain with an oil pump. It's just another one of these things that doesn't make a monster contribution. Okay, before I go to the close, I got to add one more thing about the size of the oil pumps. You know that Mexico Beetles had hydraulic lifters. You may not know that those hydraulic lifters are closer to a Type 4 lifter, if not exactly a Type 4 lifter. They are not a Mofoco lifter, but it's still a hydraulic lifter, and they used a 30 millimeter oil pump. So, just a little tidbit there. Well, hopefully you found that one interesting and informative. And like I say, most people would think that the oil pump takes a fair amount of horsepower, but there are enough of us out there, me and some of those other guys on the Samba, and we know for a fact that oil pump doesn't suck up a whole lot of power. The problem is you've got so many guys out there who spew, yes, it's a power sucker, and the voices like mine, when you go over to the Samba, we just trampled on. Nobody listens to us. But yeah, it is the case that the oil pump does not suck up a lot of power. You can run a bigger oil pump and it's not really going to cost you that much. And it's up to you to decide whether you want to do that. There are other issues with running a bigger oil pump. It's up to you to figure out what those issues are. There are plenty of other videos out there and other people. So thanks for watching. We'll do something else later.